Hello everyone, welcome to this impromptu stream from Hyricane Mod Railway. As you will have seen by the title, we are doing some wiring on the layout. I thought I'd do this stream as a little bit of a test just to see how these quick impromptu things off my phone go. I just really wanted to see how it all works and sort of if these were a viable option to do in the future if people wanted a piece of content. But we are doing some wiring today. We're just doing underneath the station area. We are just doing the area underneath Brookend Station. Because otherwise it'd mean having to move my workbench and all my drawers and stuff like that, which, to be honest, I'm not really sure I want to be doing midstream when I've only got one camera to be going at. So, next job to do is I should probably explain what we are doing, is I've already connected up all the negatives to the controller for the point motors, which is this. So I've made up these harnesses for the point motors. I think I explained this in a video. Basically, the point motors have got solder pads up here, which you can see, that you're supposed to solder your wires onto. And then you can connect them, you know, for the inbuilt switch that's in there. You connect the coils to the controllers and stuff like that. Well, because I don't really want to be soldering under the board, and I will be breaking that rule later as I explain, what I have done is I've soldered these above board on my workbench, connected them to these terminal blocks, and then I can just bring the wires round and screw them straight into the terminal blocks when I am wanting to do some wiring underneath, and it just makes it a lot easier. So what I already have done, this black wire here that you can see running along here and running over there, that is the negative feed to the controller, the common negative I guess for all the point motors. So this has been connected to every single point motor. Yep, this negative wire is now connected to every single point motor on the layout, and I am just going around now connecting up the positive for all the signals. Now I could do the positive for all the point motors, but that requires to be wired in. I still haven't mounted my CDU, which if you give me a minute I can show you, because I needed to wait for it to arrive. I needed to test that it worked, and I just needed to make sure that it was all okay, and I still don't quite have the correct connectors to connect the power supply up to my CDU, and my granddad is going to provide them. He's been today to have a look at them as well. This is my CDU. So this is my CDU. I don't know if you can see the address on the bottom. It is from www.modelingelectronics.co.uk, and it's basically a 20,000 microfarad CDU. So you put your normal supply into here, this charges up the capacitors, and then when you flick the switch to power your point motors, this dumps all the current from these capacitors into the point motor, which not only makes it switch more reliably, it also switches it with a little bit more force too, which is good, and it prevents burning out in case one of your switches gets shorted. So that is my CDU. These three wires, this is getting in the way, that come under here are the wires from the signal on the third radius line, and they're plumbed into the positive there. The reason why I haven't wired this one to a point motor is because this signal won't actually be controlled by a point motor. Every other signal will. This is just a special case because I wanted a station starter signal for the third radius. I've got one for the fourth radius because that pulls off into the siding. I've got one for the second radius because that has to control and work a runaround loop. But on the third radius line there are no sidings, so this one instead is going to be changed red to green by a simple toggle switch, and I'll wire the negatives for that in separately because it is a switch negative and a common positive. So that's why I'm skipping that one out, and I'm going to be moving along the baseboard now and connecting it up to the next signal. The green wire, which would you believe turns on the green LED, the black is the positive, would you believe? So it's technically wired wrong, but then red is for red LED, so that makes more sense, doesn't it? So the black is the positive, and that's why it's got the resistor on. It could have the resistor negative, but, you know, I think positive's the convention. So if I fold those wires around and squish them, I can solder onto them and then get a better contact for the terminal blocks. Because if I don't fold the wires over, or if I don't solder to them, the wires are actually so thin that the terminal block screw won't actually grab onto them. If I make a blob. So hopefully you can see there we've made a really nice big blob on the end of the wire that the terminal block can connect to more easily. Now the red wire. Of course, the solder just adds some thickness to it. See, it has tinned where I really want a blob to form, which is probably bad. Yep, that's why I moved my leg, because that was a rocket hot ball of solder. Sometimes I may just have to leave it, sometimes it doesn't want to blob, so to speak. Terrible soldering practice there by blobbing it on, but I really don't want solder all over my legs. Well, that was a blob, but hanging down too much there, it's not going to actually fit in the terminal block. Has that soldered? Yeah, we've got a bit of blob on the end. Again, the resistor doesn't need doing, I'll just straighten the lead out. This is a 1K resistor. Now, I am contemplating buying, because these lights really are quite bright when running on the full 12 volts, I am considering getting a pack of 30, well, I'm considering getting some more resistors to add to a total of 3,000 ohms, I think, instead of 1,000 ohms. And that will make, rather than, because OO Bill bought the same signals, double O Bill, whatever, bought the same signals, and he said he painted over them. I've tried it with permanent marker, it didn't work, and I managed to get it off before it sort of, so to speak, set. And I really don't want to be buying black paint and having to paint the signal brush, the signals, the lights, because it's too much hassle, and if I mess up, then I've messed up, haven't I? So I have a choice to make. Do I use really thick wire to make the brick gap between this terminal block, where is it, that terminal block there and over there, or do we use thick stuff? Because my granddad has given me, you know, like a kilometre, don't be daft, 150 metres of speaker cable. So I've got some left over from when I was connecting the negatives. So of course it's a 2-core cable, and I was only using black when connecting the negatives. So I've got a load of this left over from red, and I've also got a load of this left over from black, and the actual cable looks like this. So it's a fairly loose plastic rubbery sheath and a red insulated conductor and a black insulated conductor inside as well. It is speaker cable, so it's 16 gauge wire, it's very thick, and thankfully if I can get hold of the wire, the insulation does peel back extremely easy, so it is extremely easy to strip back. And I was just using the black, and when when I was not using the red and snipped it off, I just said sod it and just snipped it off, because I know I'll use little lengths of wire like this. So I will connect. Ow, I've just stabbed myself with the end of the wire. Great idea. Just excess bits of copper. Ow, I've just stabbed myself with one of them. That's gone straight into my finger. Ow, 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 ow. Ow. Yes, got it out. Tiny little splinter of copper went in. So I'm not bothering to tin the ends of these wires because they're already really thick, and you really shouldn't tin wire when you're putting them into terminal blocks, as I understand, but I really have no choice with these here. So what we need to do now is, well, I'll wire it up, and if all the colours are correct, then it's a bonus. If it's not, I just have to swap some of them around. So rather than faffing about connecting power supplies up and checking they're the right way around, I'll just wire them. Well, I suppose there is only one way it can go around, so they must be right. So those two must go like that. Those two must go like that, because when one's on red, I want the other one to be on green, and when the other one's on green, I want this one to be red. So they need to wire up these two together, and then the red and the green together. But I need to extend the original terminal block, the original harness terminal block over there. Black is positive, but also, you know, I'm using black for negative in the normal sense on here. So what I think I will do is, because when I'm using the thicker cable, you know, obviously red is positive and black is negative, it's just to confuse, so you don't confuse the positive on the signals for both the LEDs and the colour negative for the LEDs. So what I am actually going to do is switch from using black. So I will be connecting black to red, but it will make sense to me because everything else on the layout will be, you know, following the normal colour scheme apart from the signals, which is outside of my control. So I need some terminal blocks, wherever they go. I ordered a pack of 120, so there was 10 strips of these 12, and I'm already down to like a third of the pack, so another trip to screw fix, I think. So yeah, we need to, well, I can get away with 3, can't I, because they're all going to wire together. So big snips required, my big 1,000 volt rated snips, which are not, you know, I'm not a lineman, I don't even work on the mains, do I? I mean, I wired a plug the other day. Actually, this lantern that's providing some light, I rewired that plug because it didn't have a cable restraint on it. Well, it did, just that somebody had taken the screws out of it, so I repaired that the other day, and the blue and the brown wires were actually showing through the back of the plug rather than just the outer cable sheath, so I did that the other day. But I only bought them pliers because they do feel, the big side cutters, only because they do feel really nice in hand, and they are, you know, really beefy jawed. They're just a very nice thing to have, especially when cutting through terminal block like this. So I'll twist the resistors together. I will solder them, and I know this is breaking my rules. I said earlier if I don't want to solder under the baseboard, but it's just in this case easier. I meant really, I just didn't do it for these points because there's a lot to do. There's 6 connections on there, whereas little ones like this, as long as I'm careful and I've got a mat underneath me that catches any spare solder, it's really not that much of a pain to just run a bead of solder down. Are those 2 trapped? Give them a gentle tug, because if I do rip them too hard, they will just fly out of the socket. Yeah, they seem fine. And these 2 as well. To make sure I line the wires up. And yes, undoubtedly, well, almost undoubtedly, some of you watching now, or people watching later, if they do, but that hasn't worked, has it? Or people watching later will say, well, you're screwing him in upside down, why aren't you screwing him in that way? Well, because I want the flush end to mount like that underneath the board. Do I try and solder these together again? This is all trial and error, by the way. This is the first one I've done of these. So again, I don't want to pull these wires tight, because I'm going to probably cable tie all the loose hanging wires together like them once it's all done. And I don't want to rip the wires out of the terminal block or the back of the signal. So screw can just go through the holes in the terminal block. We'll probably mount it slightly to the right towards the camera so we can just get around that point. I could have mounted this wire harness this way, but I wanted all the wires to be sort of going anti-clockwise back around to the control panel. So they start from the controller anti-clockwise around the layout. Jaden earlier said video is all good, thank you. I know it's going to be auto-focusing, but I really couldn't be bothered to set up my webcam and OBS for this. So you've got my phone. Right, so now we can come back to our attention of the positive wire, which I can feed into the signal. So to save me having to put 2 terminal blocks in, what I think I'll do is I think I'll just route the positive wire straight into there, and then from the same connection over here, I can just stuff two of these positive wires in and bring it along. Because as you can see I've done here, because I sort of have points left and right, I have used the terminal block before then putting it into terminal blocks. But here I'm going to see if I can avoid that, because it'll make it neater. So if I sort of do this, because the positives by accident furthest that way, which is where the positive wire is, so that was a happy accident. If I sort of just bring this round like this and sort of make it as neat as I can and chop it about there, then I can twist it together wherever my big snip's gone, and then I can just stuff not only this in there to feed that, but also this in there to carry on to the next signal. I'll be able to do that, which should make it a little bit tidier, and there won't be quite as many terminal blocks. Now I've got to be careful that I don't rag the other terminal block down when I strip that, which I haven't. It's always a plus. So that should be fairly simple. I've brought the positive wire from the controller and I've put it in to the positive on the signal, and then this will loop out as well. So that's good. Probably should have put that in last. I'll cable clip that up later. Now we need to take the switch negatives across from the switch. So I've got another roll of red cable here, so I don't have to cut this one. Oh wow, I've already stripped that. Bloody hell. So then we want to be using black actually, don't we? Because this is now black. This is actually the negatives to the switch negatives. So let me see. I need to look on. I don't actually have to trial and error this. I can just look on top and see which one needs to be connected. So that's connected there. So that means we want blue wire, the green wire from here. So ram this bit of cable into the terminal block, tighten up. That's not going to be a massive problem. If I route it around there, the side of the point motor like that, I won't need to put a cable clip in. So if I cut that about there, I've put my snip somewhere. Oh, I love that sound. If I put all my tools in front of me, the ones I use most often, that would make more sense. Again, I've got to strip this careful so I don't rip the terminal block down. That was a train, a 66 horn by the sounds of it. Next change. Make sure it's not biting the insulation, just so it contacts the copper. Clamp you down, and then I can just, when I cable tie this, I'll cable tie all them together. So this wants to go to the other switch contact, which is third from the end. Yeah, definitely don't want to be crossing power supplies. That will end marvellously. Screw you in. Hold this up so it doesn't rip its screws out the sockets. I do like to do them fairly tight. Anyway, so we'll wind you in, screw you down fairly tight, and they will just get passed round the side of the point motor. The solenoid bar doesn't actually stick out of the end, as you can see there. I just have to force it across. That doesn't stick out the end, so cable tying all them wires together won't be a problem at all. I'll just get a thin one round there and make sure that's all hunky-dory. Just make sure I don't snag that red wire there. So now I can bring this positive wire back across. I'll probably thread it over that one as well. If I thread it over the top of this one, have I left enough slack to do so? Yes, I probably have. So we bring that wire up and over. There we go. Right, let's get these two in before anything else bad happens. So we'll just need to be very careful. I was being careful last time, but obviously the screw pulled the resistors in and either chopped that leg off or jammed the resistor against the housing of the terminal block, causing it to rip. So we can just literally push that around there, but I am going to leave enough flex to tie them together. So if I move it back there and screw it in, so they can be brought round and tied together in future. Want another screw. In the hole in the terminal, the block, screw you in. That's in. Right. Need to do as malarkey with the positive wire again. So if we bring that around at a right angle, keep it looking neat. Bring it in, round, about there. Snips, big snips. Where are my big snips? Big snips, I can't reach them. And I don't want to lose my position on the wire, so we shall have to sacrifice it to the smaller snips. So we're going to screw this wire in here. There we go. Because the... oh, that screw's come out. We'll put you back in a minute. That one wants to go in there. Then because this isn't the one for the main line that needs to be green, this one goes to the middle. Again, leave some slack so we can cable tie together when the layout is completely finished being wired. And this should be the last wire we have to put in. No, it's the positive wire, isn't it? We haven't done the positive because we needed these to go in first to gain access to it. There we go. Because the positive wire doesn't need to go into this one, I can reinstall this screw that's popped out of its hole and it hasn't actually stayed in its hole. So we'll get another one and I'll find that one another day. So this is the final wire that has to go in. The positive wire in to the signals and the positive wire that will go out to the next group of signals. And I will make sure this works before taking you above the board and then making you wonder what the hell I'm doing while I'm down there fixing it. So this wire, this positive wire now is just a length of wire that runs down here. Why are we not in focus? That runs down from here through a load of wire here and then just comes to this end, which is ready to be passed to another one of these up there and then fed out in the exact same methods. So if I energise the circuit by pressing the on button for the auxiliary supply on my controller, bang, there you go. Look at that. That is the work we have done during today's stream. So I don't know if you can see. Oh, in fact, I've already got some coaches on this line. I'll move some cameras, some houses. So I don't know if you can see. It's set for the main line. The Pullman coach travels fine through those points. Yep, the signal is green, so it can go through. However, I'm going to change the point from under the board, because if I do it from above the board, it's not going to change the switch underneath correctly, but also the point motor will change from underneath. If I change the switch, you can see that one changes to red, so now it stops, because otherwise it will derail. And then a train going into the siding, if I don't derail it. The train can go into the siding, train can come out of the siding, and that works. However, signaller decides that the mainline train should have priority. Flick it again, and we have a red for the siding and a green for the mainline. So now you can see, if there aren't a load of stones in the way, we've got a green for the train to go into the siding. It can pull out and go in fine. But a train that wants to go ahead, so it's going round the layout, stops at that red signal because it knows the signal is set for it to go into the siding. So wait for it to change. I'm going to have to do this from under the board, as I said, because that's where the point motor will actuate it from. And it just makes sure everything works fine. So if I flick the point, again, a little bit of a dodgy connection, it just needs tweaking. But as you can see, I've changed the point, and a train that wants to go into the siding now knows it can't go into the siding, and the train on the main line can happily pass through. Like so. Say if a train is coming out of the siding again, we can flick the switch, flicking the point, change the switches, and the train from the siding can then pull out. And that works like that. So, I hope this live stream has been useful, folks. I hope it's given you a few laughs, and I've been cracking quite a few jokes along the way. And I hope that it has been useful, and hopefully some of the wiring has been interesting. If not, and you just joined for the fun of watching me mess around, then thank you very much. Thank you to Jaden who joined, and Joe from Northern Transport Hub as well, and anyone else who was in the backgrounds watching. But that is what we've done today. We've wired up 4 pairs of signals, and we've managed to interlock them with the point motors. So when the point motor changes, the signals do too. So thank you very much everyone for watching. I'm going to end this live stream here about 20 minutes after I said I wanted to, but that's fine. I wasn't planning to do anything else apart from wire anyway. Thank you very much indeed for watching, and I'll edit this live stream into sort of a best moment / highlights bit without all the nonsense. So at least you still get the feeling of the live stream, but without all the random nonsense in between of me faffing about. So thank you very much indeed for watching, and I'm going to end the stream here. Do enjoy the rest of your evening. Do have a good night's rest, and I'll see you some other time on High Wycombe Railway. Do take care everyone, and bye for now.